Welcome to Python Labs. In this video, I'm going to cover very important steps as part of data cleaning and pre-processing using Python in Visual Studio Code. So these are basically the number of steps or varieties of stages or techniques that I will be applying in order to clean the data and pre-process the data. But please keep a note that it all depends upon the kind of data you will be working with. So you may not be having the need to apply all these techniques, but what I have done is I have applied the most important techniques so that you can apply most of them on your data set that you will be working with. So the first things first, I'm going to import some libraries. As you can see that there is an import warning and there's a warning dot filter for ignoring. Basically what it is just to ignore warnings related to libraries. It's one of the best practices, but it's not mandatory. It's just optional. Now the most important are these four libraries, as you can see here. The NumPy is for library to perform mathematical operations, and matplotlib for creating plots, and pandas for data analysis, and scikit-learn for machine learning. So I'm going to open up Visual Studio. In my case, what I have done is actually I have created already the file, but I will just show you how to create the file similar to the Jupyter notebook. For example, I'm going to create, I assume that you have already opened the folder. So I'm going to create a new file, say for example, data prep.ipynb. So that's the file, which is very similar to the Jupyter notebook for those who have used it. So what I'm going to do is I'm going to first create a markdown. I'll just show you some sample markdown. For example, step 1, this is the first step of the program. Okay, and then I'm going to select this to make it bold, for example, and then I click tick mark yes. So that's my first step. Now I'm going to write some code, Python code. For example, print, I will say hello world. Hello world. You see there is intelligence. That's why it is automatically writing. So I'm going to click tab, and then I'm going to basically click run all, or you can also click here run. So it's up to you, whichever you want. And then I will select the Python file, and then it will show me the hello world text. We have run, I think. Yeah, here you go, hello world text. Okay, so this is basically a kind of a Jupyter notebook for those who are familiar with. And for this particular session, I will be basically creating a file like this. You can also start writing again markdown and code and so on. You see there markdown, and then you can write your code and so on, and then you can simply run this particular piece of code snippet. I have already created my lab, so I'm going to basically go through this session with all the code, because there's a lot of code I cannot cover in this particular video. So I'll go through step by step, and don't worry, I will share this file as well in my description. So first step, as I said, we are simply importing the libraries, which I have already done it. I'm going to run this one. So it has successfully run. How you can find out? It is here. You see here the tick mark and the time it has taken. So once it has done that one, so the next step we are going to do is to read the data file. Now this data file that I'm using, it's a very classic data set we received from the hospital. For example, the data is having a lot of errors, and it will be very good for you to go through a lot of things. Let's go through these things now, and you will be able to see that how many data entry errors normally we come across that needs cleaning before we perform other stages of the machine learning. So for instance, let me open up this data set here. Let me open up the data set. You see, this is the data set I have. Basically here I have numbers and gender, age, weight, comorbidities, and then there are some data fields, and then there is post operation and total length of stay. That's the length of stay. That's the difference of the dates difference. So which means that if these are there, we don't need these fields, for instance. And then there is a pathology. For example, there is so many description. It's a text, different types of text that has been written that requires cleaning as well. And as you can see here that here, for instance, there is NA. NA means what? That's another issue. Even though the values are numerical, but those are some values which are NA. And the same thing applies to other data sets. And there are some empty columns as well. And then there are some values again here. And there is quite a lot of cleaning required. And you can see there here. And basically, like, this is basically what we received the data. And I thought let's do the cleaning, the entire cleaning step by step. So let me close this one. So let me go back to my slides, and this is basically the data set that we have. We are going to work in this one. Now the way to import the data into the Python in Visual Studio is simply use the pandas PD. Because why PD? Because we have given the shortcut, yeah, PD for pandas. You see here, pandas as PD. Otherwise you would have had to write pandas dot. Instead of that, you can use the shorthand notations that we have written here. So pd.read CSV. So once you read the CSV file, how to read the CSV file, please make sure that in your Visual Studio Code, I have already explained this in my previous video. You need to have the file here. How you need to have the file here? Just copy paste the file in that folder, wherever is that folder. Okay. So copy that folder, in that folder, just copy that file. If you haven't watched my last video, I will provide you the video link. You can go there and you can see how to view the data and also the files in the Visual Studio Code itself. Now you can also view the data set here itself. Like for example, right click, open with. I can select CSV editor. Now I'm going to close this one. You see, this is the data set that we received from the hospital. Okay, so this is basically having a lot of issues, lot of errors are there, lot of issues are there. We will go through one by one. Let's stay tuned. So that's the first step. And the second step, as I told you, we just read the data set. That is the file name. And there is something called skip initial space equals to true. The reason why we write this one is sometimes when you get the data in that data set, sometimes you see here, for example, there is a space. There is a space before the text. Those kind of things can be handled because sometimes those small one spaces can make a big difference. Okay, so that's one thing that we need to handle, and that you can do simply by writing this. But from what I have found, that even writing this itself is not enough. We will need to trim the spaces before and after the text. We will do that in the coming steps. Now let's go through this one. So basically this PDF or data frame, that's just a shorthand notation that I have given. Hold the results, whatever is in the file, in that file, hold all the data into the data frame, which is basically a collection of rows and columns. Now just it will be a good idea once you hold the data just to see the info, dot info. What does dot info does? Dot info actually gives you a general structure overview. See, this is basically showing you that these are the columns and whether they are non-null or what is the data type. And you can see here pretty clearly here, for instance, weight, it is classified as object, which is wrong. It should be integer or float. Why? Because it should be a float, because the weight is weight of a person. Now why it has classified as object? The reason is very simple. As you can see here, the weight, some of the values are NA. You see that NA. That's the reason why the values are stored as why this weight it is considering as a object, which is also it's part of data cleaning that we will do. And these are basically just a general overview of the complete different data sets. And you might have also noticed here unnamed 29, unnamed 33. What are they? They are basically, if you go through here, some of the columns are empty. Now I strongly suggest something actually before we even perform pre-processing in the Python. If you have the data by chance in CSV files, then I would recommend you to actually do most of the cleaning as much as you can within CSV files, because CSVs are very good when it comes to cleaning and all those things. But for the purpose of Python programming, I have explained here pretty much everything. I'm not going to touch, or I'm not going to make any changes in the Excel file. I will be doing pretty much all the changes within the Python programming. So let's go through this one. So basically, once we read the file, it is a good idea to basically see the what is in the data frame. .info will give you the general structure, and you can also actually check if there are any missing values and so on. I have written some code here. All you need to do is basically go back to that file. You see that you can simply, for example, if I have to just remove the comment, and I'm going to rerun this one. I'm going to comment this one, and you remember to comment, the easiest way is control and forward slash. So that will basically make that as a comment. Now let me rerun this code again. You see, now it is showing me in terms of percentages the amount of data that is actually missing or null, empty. You see, weight has 27% of columns which doesn't have weight value at all, and there's just so many other columns, and there are unnamed because these are basically these columns. Of course, they are 100% empty. You see there, those are 100% empty, those columns, and so on. It's okay, we'll go through these things one by one. Let us go through step by step. Now that we have got the second step done, that is reading the data from the file. So now the next step we need to do is, you see here, actually this is an overview. This is a very good overview that you can see that this is basically the what do you call, the raw data we received from the hospital, and what is our target? To clean it and to pre-process. Now you might notice quite a lot of things here. For example, unnamed 23, unnamed 24, those columns are gone. And also you might notice that there are some new columns here, encoder underscore pathology underscore so and so, and there are quite a lot of things. Let's go through one by one. Now step 3, remove unwanted features. This is the very first step that I would recommend. Just get rid of those features which are not needed. For instance, date of admission, date of operation, and date of discharge. These features are actually not needed. Why? I already explained to you that if you go back to the data file, you can view the data file from Visual Studio Code itself. You see here, we already have here post operation length of stay and total length of stay. Basically, that's the difference of the dates. If you come, sorry, I clicked the sorting here. Anyway, that's actually the difference of the dates. Basically, the date of admission to the date of discharge and how long the patient has stayed. If you calculate, it will basically show you the dates here. Okay, so basically that's basically, it's already there, so it doesn't really make sense to have these date columns as well. So we can simply get rid of those field columns. Let me show you here. That is step 3, which is here. So we are basically, what we are doing here is trying to get rid of those unwanted columns because we already have the length of stay fields. And as I told you, there are empty columns. We don't need those empty columns as well. So those empty columns can also be removed. So we don't want those features. Now here there are two fields here. One is called in place equals to true, access equals to 1. In place equals to true means this is the default value to commit changes. Whatever I'm making changes after this, those changes must be applied to my data frame df. And access equals to 1 means the changes that I'm going to make is at the column level. If I had written here access equals to 0, the changes needs to be made at the row level. But in our case, we are deleting columns. That's why we are basically we have set the access equals to 1. Now it will also be a good idea for you to have a look by just having print data framework.info. Once again, if I run this code, it will show me here the tick and also the amount of time it has taken. You see there. So basically, and now if you notice, compared to the previous one, in the previous step, we had these date of admissions, date of operations, so on, and then unnamed columns, those are which are 100% empty. So those columns are gone. You see here, those columns are gone now. You see here, no unwanted unnamed columns anymore, no date columns anymore. Okay, that's basically what we have done in the step 3. So basically this is what it is. So basically, as I explained to you, we delete these files because we already have the length of stay. Now again, this is also again another thing. We deleted the unwanted columns, unnamed columns, because they are simply unnamed and they are completely 100% empty. It is actually something that the data when we received, the clinicians might have had something, they cleaned that one before providing the data or something. Anyway, whatever it is, empty columns have no meaning in terms of data analysis. The step 4 is to strip before and after Whitespaces. As I told you in the first step, when we are trying to import the data, we do use the initial, remember the first step, which is here. Where is it? Import data, skip initially space equals to true. It tries to remove the space, but it doesn't work 100% for some reason. That's why it is always important that you also strip before and after white spaces throughout the data frame. It is not just that you're trying to remove the white spaces. What I'm trying to say here is, if there are, let me go back to the table here, the data table. If there are any spaces anywhere in the data file, in the entire data data frame, then those before and after spaces must be deleted or must be removed. The easiest way to do this, there are two ways actually. One is the lambda expression. I have shown you here in terms of lambda expression. You could have simply written this like if else condition. Okay, like if for example you are looping through, and then you can if else. But here there is a very beautiful easy expression. Data framework equals to data framework, which is our data set, which is what it's holding, dot apply. The lambda state basically is an argument. What is the argument? If the data type equals to object. This is very important, because we cannot apply this lambda expression or this condition on numeric values. If you notice here, like in our case, we have some integer fields, or it doesn't work. Only on objects it tries to apply those lambda expression. So if the data type is object, then you strip. What does strip means? Strip removes the before and after white spaces of a string, okay, of a string or of a value. Now if not, just do nothing, just skip it. Okay, so that's basically what it is. Now apply the strip to all the column names and as well along with the data. This one is actually doing the stripping for all the rows. But if you notice in the data set, even the text written here, which is from the medical point of view, these data sets are names are quite lengthy. Sometimes you see here the names are quite lengthy. So these kind of names, sometimes they also have beginning and the end some spaces. So it is always a good idea to clean that, strip that white spaces before and after the column names as well, along with the rows. So that code is already written here. Let me show you back again. So remove unwanted features. Again, data framework dot, we already did this, dot drop those columns, and we already discussed that one. Now the next step 4, which is I am applying that lambda expression to clean, if to strip if the column data type is object. Okay, and then apply the stripping function to all the column names as well. So I'm going to run this one. So it has successfully executed. Now the next step 5, this is again showing you the, I'm actually showing you here some examples here. Too many before and after white spaces, just to give you an idea. For example, this particular text at the end, it may seem that there is no space there, but if you click and you try to carefully look at the data, you will find that there is one space. And the same thing even in the column names as well. For example, this particular column name, you can see that there is a space. So these are basically what I'm trying to explain, that we need to remove these ones. Step number 5, we need to replace unwanted values with nan, such a or empty. Nan is basically null values, no values, no empty values. I'm sorry. So in our case, for example, we have some records with capital N slash A, NA, NO, N backslash A, N backslash A. These are some kind of values that are actually there, and these are basically some kind of garbage values. Or not available in other sense. From the medical point of view, they have written it because for them the data was not available. From the medical, from our machine learning point of view, these values can hinder our analysis. You see here NA for the weight. Okay, fine, but at least this data needs to be empty, at least, so that we can perform some other techniques that I will cover in the coming steps. The same thing again in this particular this is basically applying throughout the data frame, not just for a particular column, but for the entire data frame. Now these ones we are particularly applying for a column called neutrophils, and these ones, these less than, greater than, and so on, we are particularly applying on the CRP column. And because those columns had some issues, like for example here you see here NA, these are basically garbage value. Garbage in is garbage out, we know that. That's why we need to clean them. It's a lot of cleaning. And the same thing applies for other columns as well. Like for example in the CRP, there were some, like for example, let me go back to the data file. In this file CRP, There is the CRP here. CRP, it had some values like greater than, less than, and so on. If I can show you something like, for example, here you go, less than 0.1, which is not good, because that less than, we cannot convert into numeric or float values, so that's an issue for us. So we need to get rid of those kind of things as well. Now again, as I mentioned to you before, not all the steps that I am performing might be applicable to you. It all depends upon the data that you are going to work with. So for me, in my case, in this particular data sample that I'm working with, it's real data that came from the hospital, and these are the kind of issues that were there. I have basically applied these kind of techniques. Now from step 5, step 6 again. Now in step 6, what we are doing is, some of the, as you can notice here, the data that we got, it's classified as objects. Now the problem is, once we have cleaned the data, in other words, we have got rid of all those NAs and so on. Now it's safe to convert it into different data type. For example, float data type, because weight is indeed a float data type. And the same thing we can apply to the other columns where we have performed the data cleaning. Step 7, let me go through the code as well here. Let me go back to this one. So step 4 is done, and sorry, step 4 is done, and step 5, now I'm going to replace, and then I'm going to perform the step 6, which is convert specific features from object to numeric for machine learning. Now what is step 6? Again, let me go back here. Convert specific features from objects to numeric. This is very important, because in machine learning you cannot have text data for many algorithms, so it is very important that we convert them before we can perform our modeling techniques and so on. So step 6 is also done, so I classify that as done. So step 5 is done, step 6 is done, so that means, see, there's the tick mark. Now I go to the step 7. Now step 7, what is step 7? Converting the binary values, yes or no features values, to 1 or 0 for machine learning. Now as we can see in our data set, we have so many features which are basically yes or no, yes or no. You see here, yes or no, yes or no. Now these kind of features, yes or no, we need to convert into basically, for instance, here what it is saying from a medical point of view, if you can look carefully, what it is saying is diarrhea. Does the patient have diarrhea? Yes or no. Does the patient have nausea? Yes or no. Does the patient is the patient vomiting? Yes or no. So these kind of yes or no kind of scenarios, what we need to do is, we need to convert them into a yes as 1 and no as 0, because it's a binary values. So basically, like, all these, most of this data framework, hospital readmission, diarrhea, nausea, vomiting, and all those ones which are binary type, you can simply create an array, order of yes means 1, no means 0, and then you can map them, you can map it. So once you map, what happens is, all these attributes, basically, which are binary attributes, then you are saying that convert those ones from text or binary text character to numeric value. So that's basically what we are doing in this step here, if you see here. So I'm going to run this one again. Once I do it, it's done, successfully done. Now step number 8 is, let me go back. So step 7 is done. So this is basically how it looks like. Before, the data is no, yes, and so on. Now no means 0, yes means 1. I hope that's clear. Step number 8. Now we are converting a category variable such as gender using label encoder. Now you might be wondering, do we really need to use this technique? The answer is no. Actually, there are a varieties of ways to do it, but I'm just showing you one way of how you can use this method called label encoder. This label encoder can help you, especially if you have labels like, say for example, there is a gender male, female, unspecified, or something else. Then in that case also you can use this kind of technique. What it will do is, it will assign male 1, female 2. If there is one more, for example, unspecified, then 3, and then something else, then 4, and so on. So it does pretty nicely on its own. So but in our case, because we have only male and female here, so for males, you see here, before it was M, it has converted into its equivalent after applying LabelEncoder, which is from the scikit-learn. You need to import this LabelEncoder and LabelEncoder, and then you basically apply that for that field, whichever attribute data framework of sex equals to, and so on, transform. Again, this is just one of many different ways. Whatever I'm explaining you here is just one of many different methods. You can also consider using OneHotEncode encoder, or you can there's also another you can even do this by manually. For example, like you can just have this kind of code here. I'll just do this. You see here, gender equals to, again you assign, and then you can map. You can also do these kind of things. So I leave this one again. Now step 8 is done. So it's successfully done. Now step 9. Let's go to step 9. Step 9 is, in this particular scenario, what I came and noticed was there is a particular column with so many spelling mistakes, but all of them are pretty much same actually. If you see here, laparoscopic appendicomy, the same thing. There are typos and so on. The values at the end of the day, it's all same. So basically what we can do is, if that's the case, from the data framework you can even write something like this: I locate. This one column before and after means this is actually for the rows, this is for the column number, this is from the column number. Basically what we are trying to say here is, from, if I have to write, for example, I could have written here I log, and then say for example 1 to 100 comma say 26 comma 27. If I have written like this, what it means is, for the records, for the rows, for the first 100 rows, apply this particular change for these columns. So that's basically what it means. Anyway, in our case we don't need that here, because this is applicable for only one particular column, which is this one here, column for located at number 26. So that is basically what I have done. And step number 10. Now convert the text data features into categories. Now this is another important step. Now, as I told you that for machine learning, machine learning, many algorithms, they don't like categorical values. So here we can see that there is quite a few examples. For example, in this particular case, comorbidities. Now if I go back to the data, raw data, in the comorbidities, what happens is, you see here, there is some text here, and say for example this text, for example, hypertension. Now here the doctors have written some kind of medicine, medical notes. However, in the other fields, it's all written as no. Sometimes it's capital N no, and sometimes small n no, and so on. Now after discussing with the medical doctors, the doctor said, if something is written, which means just make it as true. Yes, there is comorbidities. And if nothing is written, or if it is written as no, which means consider them as a 0. So this is something that you need to verify, especially with your domain expert, whichever project you are working with. So here in this particular case, again, if it is no, or if it is null, you see, if it is no or if it is null, so basically set the value of 0. Otherwise, the doctors have written some notes, which means set the value as 1. You see here, this is how basically we can write. Now again, we need to convert this, because the data type is an object type. But now that we have converted into numbers, then we need to also set as type to integer. You may also double check the properties of the column, whether to make sure that the values are correctly coming or not. Like, for example, .info, as I used before. So if I go back to step number 10, so let me actually, I think I have executed step 8. Let me execute step number 9, and then step number 10. There are quite a few things here. Actually, let me show you the next steps as well. So if I go back, if I go to the next step, you see here, there is another categories. Again, what it is doing here is, we have so much text written in the column called pathologies. In the column pathology, there is so much text written, but again, discussing with the domain experts, the doctors, they basically said, if a text is written, like, for example, early appendicitis, that means it can be classified as EAP, acute appendicitis, ACP, supportive appendicitis, SUP, and so on. So what I'm trying to say here is you first categorize the data. You categorize the data into groups. First, you categorize the data into groups and and set them as category. Now you may even check what are the unique values. So these are the unique values that you should see, technically speaking. So for example, you see here, in this particular case, the first one, as I told you, if there are no, it is set as 0, while any text written by the doctor, then those text for comorbidities is set as 1. So this is how for the first thing. And the second one, which is about covering the text data first into categories. As I told you here, there's so much text written there. These are basically, you can even perform text mining and all those things, if you really want to. But in our case, according to the domain experts, you need to basically classify. If there is a text called acute appendicitis, just classify them as ACP. If there is a text, superior to appendicitis, then classify them as SUP, and so on. So the easiest way to achieve that is basically you can write some logic here. Now again, I have used the simple if for if conditions. You can also use the same thing in lambda expressions if you want, but this is one of the easiest way to write. So for index comma row in data framework dot iterate rows, and if it's going to loop through all the rows, and then it is going to check if the string, again I'm checking it to lower because sometimes there might be caps and so on. If this text exists in this particular record, then consider them as EAP. And the same thing, if acute appendicitis exists in this particular record row, then classify them as ACP, and so on, else classify them as other. So this is basically one of the best ways you can classify. Now once you have done this, so all the text data is now converted into categories. So that categories are there, and now you can also, for the testing purpose, you can write and check all the unique values. You should have this kind of thing. Let me run this code here, this code. So you can see that these are the unique values the system is showing. There are 6 unique values. Basically, obviously this is 6 because we have 6 categories, 1 2 3 4 5 and 6. So these are the 6 categories that the system has successfully assigned. Now let's go to the next step of data pre-processing. So this next step is a very important step actually. It's called OneHotEncode technique. Now what it is, see, sometimes we have the data in categorical values, right? Right now in our case, we have converted this entire text data, which is this one, pathology, all this text data. We have classified this data into different categories. Now once you have classified into different categories, 4 categories, 5 categories, 6 categories, now you cannot simply assign the value. First category is 1, second category is 2, and so on. I will explain to you here. Look at this. What I'm trying to say is, look at this one here. You see here, basically once the data has been converted, you cannot just cannot assign like ACP means 1, EAP means 2, fall means 3, and so on. Why? Because machine learning will assume the weight of 3 is more than 1. But that is not the case here. All of them are equally important. All of them are equally important. How do we, in that case, convert the text categorical data into numerical values? There is a beautiful technique called OneHotEncode. Now, what this OneHotEncode does is basically, for example, here, how many categories are there? We have 6 unique values here, 6 unique values. So it will create 6 unique columns. See there? It will create 6 unique columns. And then for each column, for example, ACP, the first one is ACP, categorized as ACP. So ACP is set to 1, the remaining are all 0. And the same thing, for example, here SUP is set to 1, while the other values are all 0, and so on. So what it means is we are going to have extra 6 columns, which means we will have to even delete this pathology column, and 6 new columns are generated. So this is basically one of the, this is actually an advanced technique, and it's one of the best practices in machine learning, which is very much needed, especially if you have data in text in different categories, and you want to convert those categories into numerical values. I hope that's clear here. So here, this is the example of how the data looks like. You see there, the 6 categories, so 6 columns, and then wherever that value is category is there, then it will basically enter as 1, the remaining as 0. And you can also search and view the information in Python here. So convert the data again. The way you do is we have to convert the pre-processing, import OneHotEncode. You have to import this one, and then column transformer. Now here we create an instance of the column transformer. Now once you create a column transformer, I think I have written the text here, if I'm not mistaken. Here you go. Yeah, same thing. Okay, fine. So it's the same thing. So basically, like, this is the way you specify which column you want to split from categories into numerical. Remainder equals to pass through means, do you want other columns to be with or without this result? In this particular case, I just said, okay, hold the remaining columns as well. Now then what you need to do is, you once you get the returned values, you hold it and then you convert them into a data frame, because the values that you get is actually in arrays. Now once you have the values in the what do you call the one hot encoded data, you basically, what you need to do is, you need to get the feature names, or you can write your own names. If you see, these are basically new columns that the system would generate. Encoder underscore pathology underscore EAP, encoder underscore pathology underscore ACP, and so on. So these are 6 new columns. The what do you call, the system has generated, which we are holding here in an array. And then we basically, for the purpose of testing, for the purpose of basically, like, to check whether the values are, how the values have been split, you can even export. For example, here I have used the export function to export into a file called lab2.ohe. If I open up that file, let me open up that file, lab2.ohe, which is this one here. You see there, this is how the data has been split. You see here, new columns. These are the new columns that have been generated, that have been created after applying the OneHotEncode encoder. So I close this one again. Now I'm going back. Now this is, as I told you, this is basically how it works, and this is how it converts, which means there are new columns that have been generated by the system. So if I go back to the coding, now these are basically the columns that you can even verify here after running. You see, video I have run this. So these are the new columns. The one hot code encoder OneHotEncode has generated. Now step number 12, again, now that we have got some kind of data, now we are all working with this. And now please make a note here, this whatever we have generated, these new columns with OneHotEncode, the data is stored in enc underscore data. Now we will not be touching this data, or we will not be touching with these new extra columns, because now we have to deal with the missing data. Now it will be pointless for us to look into these columns, because these columns are already generated by the system. So the system has taken care of it, which means we don't need to apply any kind of techniques to handle missing values in these newly generated columns. So that's why what we need to do is, we first specify which columns I'm going to check for any missing values. Now that's basically what we do with the help of KNNImputer. Now what is KNNImputer? KNNImputer is a method or a technique when there is so much cell values, there is empty values, empty data, then it will try to fill those empty values with the help of nearest neighborhoods, which, like for example, there are so many records there, and some of the records, some of the cells are empty, then it will try to find the nearest neighborhoods and then it will try to fill it. Now this is one of the advanced concepts. There are many different types of imputation available there, but I'm just showing you one of many examples, and KNNImputer is one of the best, actually, one of the best compared to other techniques. So this is how you can see. For example, there are so many empty cells here. Now those empty cells, what KNNImputer does, it goes and tries to fill the values. You see that those values are filled. This one is 0.9, it is already there. So basically I'm talking about these empty values. You see here, there's so many empty values. These empty values can be filled by the KNNImputer. So I'm going to run that code, basically the same thing here. So the way you do it is you first hold the columns that you want to apply the imputation, and then you call an instance of the class for KNNImputer, and then you basically specify all the columns, and then it's again in the data framework, these are the columns that I want to apply imputation. In other words, I want to fill the missing values. Normally these are basically all the columns normally, but in our case pathology, this column has been removed. Why? Because we have applied one hot encoding in the previous step, where this pathology now is converted into 6 new columns. The another point to consider is the last column, which is the target class, complicated. Now that column also, it is not recommended actually, but unless if you have some data, empty data, then you can consider having it to fill with empty cells as well, but it's not recommended. Now let's, once you have the data, you can actually export the data, and you can see, for example, here I have got a file called lab2knn. Now let me run this file. Once I run this, now it is successfully executed. So I'm going to check the KNNImputer. Now you will see that all the data is pretty much completely, it's full. There is no empty cells, there is no null values, because the system has gone and filled all those empty values, you know. So that's basically how it works, KNNImputer works, and it's really amazing. So we go next. So all the empty values are filled, and now apply rounding. Yeah, sorry, step number 13, apply rounding. Now why rounding is needed? Now you might have noticed something here. For example, I'll show you one strange example. Now, for example, in this particular case, you see here, these cases, for example, if you remember diarrhea, what we said, the doc, according to the domain expert, diarrhea is basically here, this column is showing if the patient had diarrhea or not, if the patient had nausea or not. In other words, it is 1 or 0 kind of things. But when you applied the KNNImputer, it has applied in a kind of a floating values, 0.8 chances, 0.6 chances that the person had nausea, 0.2 chances that the person had diarrhea, because these are basically empty cells that the system has gone and it has tried to fill, but it makes wrong interpretation of the data. So what we need to do is we need to do rounding here. Now rounding function, we all know rounding, we round up or round down, and basically that's basically what it does. For example, you see here, if the value is greater than 0.5, it has considered as 1. If the value is 0.4 less than 0.5, it has considered as no. So yes or no kind of thing scenario, you see. So this is basically how we can achieve easily with rounding. It's called you know, see, NumPy has this function called rounding, and then you pass all the clean data of data frame and also the column names. It's already there. So once you do this step, which is this, you see, apply rounding function, I apply those functions, it has successfully executed. Now the next step is make sure if the data after rounding is cleaned and there are no anomalies. You know, it's always good to see. In this particular case, I have exported the data results into lab2 rounded values. So I can go there and I can check lab2 rounded values. Now let's see what the data looks like, how the data looks like. So this is how it is. Look at this, beautiful. Now if you see here, this is how the data was with all those 0.84s and all those things. Now the values are pretty clean, ones and zeros, and you see there. So this is basically what I was trying to explain. Everything is now clean, pretty clean. It looks much better, and there are no anomalies of 0.2, 0.8 and so on. So we perform, once we perform the step 13, as we see here. Now the next one, again, I have already shown you. You can also see the data export and see the data results, or you can simply click dot head in the clean data. The dot head, it will show you the results here itself. You see here, once I execute these results, and the results, it will show me in the, once I click this one, you can check the, sorry, it is showing export because I have opened the file here. I need to close this file. If I close this file again, now again, if I rerun, it will export, as well as it will show me the clean dot head. So the values are clean dot head. This is how the clean data looks like. Now once we have done this data set, clean data set, now the first things we need to do is we need to split the data based on independent variables and dependent variables. Why? Because we are going to apply something called scalar function for the independent variables. Now, what is independent variables and what is dependent variables? Dependent variables is actually the target class, the target. Okay, whatever is the target we are trying to predict. Now, the way you can split is very simple. You can see that whatever the data frame you have, dot drop, you just drop the last column, and the column axis equals to 1 means at the column level. So that means you have all the data except the last column. On the last column, you just specify the name of the target class. Okay, so that's basically how you can store in the form of this in X and Y. X holds independent variables, Y holds the dependent variables. Step number 16. Now what we are going to do is we are going to apply something called minimum maximum scalar function. Again, there are many different types of scalar functions available there, but MINMAX is one of the best. Now what is the purpose of this one? That is the most important thing. Now you see here, if you look at the data set itself, like for example, rounded values, you see here what the data we are seeing here is some columns age is out of, say for example, out of 100, weight is maybe 100 or maybe no or something more than that, but on the other hand comorbidities is 1 to 0 to 1 and so on, while other fields you see here basically different columns are in different measurements, different measurement levels. That can cause problem as well in machine learning. So what we need to do is we need to apply scalar feature. It's very important, because feature scaling or scalar feature scaling is very important to ensure all the independent variables are normalized. In this particular case, we want all the values between 0 to 1, all the values between 0 to 1. So the one of the best methods or techniques that is available is called MINMAX Scalar. And you can, basically I'm just showing here how to apply, and then you're holding the values, and then you basically, like, you can even check what the values are holding now after applying the min-max. So I want to apply on the X. Now what is X? In our previous scenario I told you already, X is the independent variables, Y is the dependent or target class. So we want to apply this min-max, rounding up and down, rounding between 0 and 1, for all the columns except the target class. So this is how the data looks like. Before, the age was 37, 45 and so on. Now the age is also between 0 to 1, as you can see. Weight is also between 0 to 1, and the other columns are also 0 to 1 and so on. So different range values for different features. Now all the features are normalized between 0 to 1. So step number 17, again, you need to, now this is basically, this step is actually optional. What I'm doing here is, once we have done the scaling, we have prepared all the data, I'm trying to merge all the independent variables and that, also the newly created variables with one hot code encoder, and also the target class. So just trying to merge, combine everything so that we can see it properly and make sure that the data is ready, because that is the most important thing. So in this particular case, step number 17, so I will basically apply 15 is clean, and we have already discussed that one. Step 16, scalar function, and then step number 17. What we are doing in step number 17, let me actually close these Excel files. Step number 17 is to merge and display all the results. Okay, so I have got these results in export into CSV file. Let's open up the CSV file. What's the name of the file? Data clean. Okay, not that one, this one. That's the raw data. So this is the clean data. You see now the data, the entire data set is ready now. Now basically what you see here is, you see all these columns which are basically between 0 to 1 after cleaning and filling the missing values, after converting and so on. And then we also see the encoder function, new columns that were created in terms of the text, I think it was pathology, and then our target class. So this is basically a perfect file that is ready, pretty much ready, and all the data is scalar between 0 to 1, and this data is pretty much ready for performing the machine learning, applying the machine learning models. Now let's go through the next steps. After merging, you see these are basically independent variables. These are the it is sorry, this is not independent. Yeah, these are independent categorical variables after imputation, after applying imputation, and this is the dependent, the target variable. The last thing we need to do is, now that the data is clean, everything is ready, we need to split the data into one called training set and the other one is the test set. Now what is training and test set in machine learning is, if you are running a model, whichever model it is, you basically train the model using the training data set, and then you check if this is really working or not on the small piece of test set that you have separated. If you don't separate this, what is going to happen is, you will not have the new kind of data on which you can apply the different models and see whether it is working or not. That's the most important here. So we need to split the data in order to perform different models on training data, and then we compare our performance results, for instance accuracy, performance, etc., using the test data. So this is how we do the splitting of the data. So you split the data. Here I have set 0.2, which means I want 80% of the data to be training, while 20% of the data to be test. So our models will be trained with 80% of the data, and then we will be testing the performance, accuracy, etc. on the remaining 20% of the data. So that's basically what the step number 18. So if I basically go to step number 18, I run it. You see here what is happening here is, I'm actually importing the training test split. So x train, x test, y train, y test. Why there are four categories here? Because we have two, if you know that we have what do you call, testing set and training set. The testing set and training set, so we divided the data into testing set and training set, and in each one we have, this is 80% testing and 20% training, and in each one we have what we call as x value, which is this independent variables, and the y, which is the target class. The same thing here, x is independent variables and the y is the target class. So both of them we have test train, test train. So that is the reason why we split into four categories. Now on another important task, now that we have got the data cleaned, we have the data which we have split into testing and training. But the most important thing is, we need to check if the data is really imbalanced or not. What is the imbalance here? Now imbalance means, in our target class, our target here is, for example, the complicated. You can see that majority of the records based on the features, the target, majority of them are actually no complications occurring, no, and only some of them the complications are saying that yes. This can cause problems as well, because when we try to apply the machine learning algorithms, then majority of the cases are no. That's why it will treat that no is always the right answer, and so on. So an imbalanced data could lead to inaccurate results, because here 1 is minority while 0 is majority. I'm talking about target class here. I'm talking about target class. So that is really not good. And what we need to do is, we need to perform balancing. We need to perform balancing here, which means make sure that the data having enough records, that testing testing and training data set. Within training data set, the target whatever the target, in our case here complication, is having equal chances. That is equal chances. We need to balance the training data. How you can do the balancing the training data? There is a technique called SMOTE. SMOTE, what it does is, it has again many techniques. I have applied oversampling. What it means, the one which is minority, in this particular case the minority is 1 in my target, so it will try to add some extra sample data, so that both of them are balanced. Both of them are balanced. So we can use the oversampling technique, and we pass in x train, y train training data, and then we can basically check that that in my case I have used the default values, but you can also specify certain parameters. For example, you want 10% training, 30% test, and it's totally up to you, whatever you want to specify, but the default is good. I found the default works really quite good. So now the target class complications, it has equal number of records, and that is really good. Now you can even verify that one. What I have done is, in this particular case, for example, once applying this one to split the data into testing and training, and then you basically apply value counts. You see here, this is another way to find out that zeros are many in the target class and one is less, which means it's a minority way. Another way to find out is in a nice graphical view. You can even view the data results in the view. You can see that one is less and zero is more. I'm talking about here the target class, which is client complicated. Sorry, the complications, there are less ones and more zeros, which means that it is data is imbalanced. So you balance the data after applying with this one. I have applied the data set here again, and now once you apply, now you check again, verify after applying. You see now we have balanced data. What it means, now I need to show you what it means. Let me show you by exporting the results. I have exported the results into a file called smote.csv. So let me open up that smote.csv. Let me see here, show you here. Let me actually make this as a table, make life easy. So this is like a table, insert table. Now if you see here, the number of complications, if I just select 0, how many records I have? I have 267 records. Now if I filter this again with 1 instead of 0, and then I click OK, also I have 267 records, which means the number of complications 0, number of complications as 1, both are equal, which means balanced. So that because at the end of the day, our aim is to do prediction given these features, whether the patient will have complications or not. Given these features, whether the patient will have complications or not. We are not after this kind of imbalance kind of scenario. So now if you see the previous data, if I open up the previous file, maybe this rounded values, and let me show you here. If I again convert this into table, you see we have total of 415 records, and if I basically select complications as 1, now you see the one has only how many records? 79 records, which is not good, because the other category, which is the complications as 0, if I click OK 1, now the number of records are 335. This is completely imbalanced. That's why in order to avoid this kind of issues, we can use the we can use the SMOTE technique. So SMOTE technique will ensure that the target class will have equal number of chances by adding extra sample. We use over sampling so that it will generate some extra rows to ensure both the columns are there. So that brings an end to this Python lab. And stay tuned. In the next lab, we will be covering some amazing modeling techniques, how to select the models and how to train the model. Thank you for listening and have a wonderful day.